Hi everybody, and welcome to day one of adding and subtracting rational expressions. We've been doing a ton with rational expressions, simplifying, multiplying, dividing, so now it's time to get after adding and subtracting. So although adding and subtracting are the simpler of the two math operations, well, a lot of people think they're the simpler of the two, they actually require you to follow the most amount of rules. So we are going to just remind ourselves about how to add fractions to begin with. Today we're going to focus on what happens only if you have a common denominator, and then in other days after this we'll focus on what happens when your denominators are not the same. So if we're just focusing on the common denominator, adding fractions with a common denominator, then all we need to do is add the numerators, keep the denominator. So this would be 3 over 7. And what that kind of equates to is the reason the denominator doesn't change is because if you have 1 out of 7 pieces and I give you 2 more of those pieces, then you literally have 3 out of 7 pieces, which is why your denominator doesn't change. Our next problem, 4/5 plus 1/5. So denominator will stay the same. 4 plus 1 is 5. Now 5 over 5 can actually reduce. 5 goes into 5 one time, so we're just left over with 1. Now we've been doing a lot of this simplifying before, so even with numbers, we're still going to make sure we simplify at the end the same way we did with rational expressions. And then our third example here, if we have 11 over 18 plus 3 over 18, keep your denominator, add your numerators. Now, again, we've been practicing how to reduce by dividing what's the biggest thing that can divide them, but I just want to kind of come back to our process with rational expressions. What are the factors of 14? We've got 2 and 7. What are the factors of 18? We've got 2 and 9. Our 2's will cancel out, and so this will reduce to 7 over 9. So we're going to use this strategy here to help us add and subtract rational expressions, so something that looks like this. Okay, so let's take example 1. We've got x minus 5 over 3 plus 7x over 3. So you probably noticed they already have the same denominator, which means we get to keep that denominator. And then all we need to do is add the numerators. So some people like to kind of smush it all together. Some people like to just add it in their head. It doesn't matter. For those of you who prefer to see it, I'm going to write it out. So we're going to add x minus 5 plus 7x. Now we just need to find our like terms. So x and 7x. So we've got 8x minus 5 over 3. So now when we look at this, we need to see if we can reduce it. So the same way we reduced things up here, we need to look for their factors so we can cancel their factors out. So if we look in our numerator here, this is a binomial and it's not squared, which means the only thing we could potentially do is take out a greatest common factor. But 8 and 5 don't have a greatest common factor, so there's nothing we can do there. 8x minus 5 is one entire factor. It will only cancel out with another entire factor. There is no 8x minus 5 in the denominator. So this is the best we can do, and that's our answer. All right, if we look at example 2, 5x plus 7 over x plus 3 plus x plus 11 over x plus 3. You see that we still have a common denominator, so that's going to get brought over. And then our numerators will get added together. So we've got 5x plus 7 plus x plus 11. Again, you might not need to do this step, and that's totally fine. Some of you guys can just look at this and add in your head. So 5x plus x is going to give us 6x plus 18 over x plus 3. So we're kind of in the same boat we were over here. There are no squareds, which means the best we can do is hope for a greatest common factor. 6 and 18 actually do have a greatest common factor of 6. So if I take that out, I'll be left with x plus 3. Now this is an entire factor that matches an entire factor in the denominator, so these entire x plus 3's will cancel out, leaving us with just 6. Okay, so we did a couple examples with adding. Let's do a couple examples with subtracting. So subtracting and adding are no different. You still need a common denominator. The place where people tend to make mistakes, though, is because this is subtraction, we forget that the entire fraction is being subtracted, not just the first part of it. So I actually like to write these ones out for sure. With the adding, sometimes I'll do those in my head, but because we are going to be subtracting the entire fraction, so I don't lose a sign somewhere, I always write these out. Now my denominator is still the same, so that's going to stay x minus 1. The first numerator won't change because there's nothing being done to it. So 2x plus 6 minus. Now my second numerator I'm actually going to put in parentheses. And that's just the visual signal for my brain that like, oh yeah, this minus is getting distributed to both of those. It's not just going to make the x negative, it's also going to make the 7 negative. So we're going to have 2x plus 6 minus x minus 7 all over x minus 1. So we're just at the point now where we're going to add our like terms. So x minus 1 over x minus 1. Oh my gosh, I love these problems. They are so satisfying because this entire factor cancels with that entire factor, and we're left with just 1 all the way down. So beautiful. Okay, we're going to hit one more example here. This one is just going to require us to do a little bit more factoring. It might look a little more overwhelming than the other ones, but we're still going to start the same way. Do we have a common denominator? We've got subtraction, so we're going to remember subtract the entire fraction. So I'm going to challenge you, pause the video, see how far you can get before you start again. All right, so x squared minus 8x minus 9 is our common denominator, so that guy's just going to come over. My first numerator is going to stay the same. My second one I'm going to rewrite and put in parentheses. Again, some of you will not need to do this, but I can tell you that in the many, many years I've been teaching, the place where people make a mistake on these problems is forgetting to distribute the negative. So writing it out sometimes just gives you that extra insurance that you'll remember to distribute it. So that's going to give us 2x squared plus 5x plus 2 minus x squared minus 3x minus 1 all over x squared minus 8x minus 9. So still no different than before. We still need to add our like terms to see what this kind of simplifies down into. So that's going to leave us with x squared plus 2x plus 1, and then x squared minus 8x minus 9. All right, so everything we've done so far has had linear factors in the numerator and the denominator. So linear factor means there's no squared, there was no squared, there was no squared down here. So this one has squared. So what does that mean in terms of our simplifying? It just means we have to factor it out and see if anything cancels, just like we've been doing for the last several days. So x squared plus 2x plus 1 and x squared minus 8x minus 9. So if you got to this part right here, you are doing awesome. We need to take one more step to see if anything will cancel out by factoring it. So if you'd like to pause the video again, pause it, see if you can get it factored, see if anything will cancel. So x squared plus 2x plus 1 is going to factor into x plus 1, and x squared minus 8x minus 9 is going to be x plus 1, x minus 9. So then our x plus 1 entire factor cancels with that entire factor, and so we're left with x plus 1 over x minus 9. Now this x and this x will not cancel out because this isn't an x, it's an entire factor. It's an x plus 1, so it's only going to cancel with an entire factor of x plus 1. So we can't cancel just the pieces, we can only cancel entire factors, which means that's the best we can do. If you have any questions about what we were doing today, please reach out to one of your teachers. Otherwise, you have a fantastic day.